Good day, doctor. My name is Ho Jaan from Year 1, Bank Section 3. My number matric is B0222100073. And my group member are WINNIE TING from Year 2, Bank Section 1. Number matric is B0221100097. And HUEY from Year 1, Bank Section 3. Number matric is B0222100084. Today we are going to present our assignment, which is Verilog HDL. Before we start our presentation, I will going to introduce the purpose of this assignment. The purpose of this assignment is to introduce counter using SFN in Verilog. In this assignment, students have to create a synchronized digital system that employs a counter to detect and identify student ID. Next, I will pass to my group member, which is WINNIE, to present the code.
Now I proceed with the coding. Our task is to create synchronous digital system that can identify student ID as a password. The student ID is inserted into coding and produce an output logic high for three clock cycle. First, we divide the coding into three parts, which is part 1 counter and test bench. Then we check the coding by select simulation and click behavior check syntax. For part 1, we declare input and output. We have 4 input, which is reset, enter, value pass, and pass in. Value pass is the password we try to detect pass in, and pass in is the correct password. For output, we have access, alarm, and counter. Now we proceed. We move on to the next module, which is counter. In counter, we create a code that triggers an alarm. The alarm will activate if the wrong password entered 3 times. The alarm can be turned off by reset the coding. We design the test bench to test our function of coding. In test bench, we set the reset and enter to 0. Then we set the same value to the value pass and pass in. First, we try the correct value. Then we look at the output is high. Then we enter the wrong value pass. The enter is 0. Then we enter again 2 wrong value. The alarm is on. Then the reset will be turned on to turn off the alarm. After the alarm turn off, we enter again the correct password and twice wrong password. Lastly, we enter again the correct password to ensure our module can run normally. Now my friend will run simulate behavior module to get timing diagram.
Okay, so this is the output waveform after the coding. And then we found that when we first enter the matrix number, the access and enter will be triggered. And then when we enter the correct number matrix, the access will maintain 3 nanoseconds and then we turn it off. So when we enter the wrong number matrix, the number will be added into the counter. When we added until 3, so the alarm will be triggered and it will keep on status until it meets the reset clock to turn the alarm off and then it's a new start over for the pass in key in. So, and then this is the functional block diagram from our circuit. And this is the full schematic for our coding.
So now we can see the result. This is the result for the block diagram. It looks like this. And this is the result for the schematic diagram. And next is the full schematic diagram for our assignment, very long. From these assignments, we can discuss that this assignment is to create a synchronized digital system that will identify student ID as the passwords. The student ID is inserted into the coding and produce an output for 3 clock cycle. The alarm will active if the wrong password is entered for the 3 times, and the alarm can be turned off by reset the coding. First, we divide the code into 3 parts, which is part 1, counter and testbed. Then we check the coding by select stimulation and click behavior check syntax. We declare the input-output in part 1. In counter, we create a code that triggers an alarm at third incorrect passwords is entered, which means that if the incorrect password is entered for 3 times, the alarm will trigger. For testbed, value pass is the password we try to enter to detect the pass-in, and pass-in is the correct password. We set 40 bits 02221000x84 as our value pass and pass-in at the beginning. So the password we set is 40 bit 0222100084. Then we run stimulate behavior model to get the timing diagram. Next, we change the value pass and pass in from binary to hexadecimal value, and the value will get B0222100084, which is the student ID. Enter is 1 when value of value pass same with the value of pass in. Then access become 1 for 3 nanoseconds. That means that the password is correct. When the password is wrong, access equal to 0 and the counter will start to operate for count for T time. Then the alarm will start to operate. The alarm will stop operating when the reset is applied. We select the implementation and click the view RTL schematic diagram to get the schematic diagram output. So this is our discussion for the assignments. Next, last but not least, in the conclusions, students are successful achieving the target of the assignment required. From the assignment, the basic understanding of design stimulations, synchronized digital system can be improved. Besides that, the Verilog code can be learned from after the finishing these assignments. Students able to learn how to design the synchronized digital system to generate and output logic high for 3 clock cycle when metric number sequence was correctly detected have been solved accordingly. Then the system will then go back to its waiting state and wait for another user to enter the new sequence. The state diagram will be produced in order to solve the issue. Once the FSN detector property identify the ID number sequence, then implement and apply the best Verilog code is in ISC project Navigator to build the real state diagram of output high logic for 3 clock cycle. In addition, there have been several attempts to improve the quality of mapping through solving design problems. This is done to make sure the state machine can communicate easily between each state. Finally, the key to complete this assignment successful is the collaboration for our group mates. So that's all for us. Thank you.